Hi, welcome to today's lesson, which is lesson 5, and we're going to talk about distance and the Pythagorean theorem. So we're going to use the Pythagorean theorem to answer some questions calculating distance, and then also some word problems. So what we're going to do, this will be connected later on to what you do next year in algebra when you find the distance formula, or in geometry as well. But what we're going to use is kind of a shortcut to finding the length or the distance between 2 points. So first let's go ahead and plot our 2 points, 2, 2, and 3, 6. And you'll need a calculator handy to figure out this question here, one that has the square root button on it. So let's get started here by finding the distance between these 2 points. Now, we've done a lot this year with finding slope. So, if we have a line connecting these 2 points, don't write this down, just kind of take a look real quick. If we have a line connecting these 2 points, we know that we can definitely count the distance up and over and write down change in y over change in x. But that's not what we're doing here. And it's very similar. The setup looks the same, so I want to make sure you don't get confused on what we're actually looking at. What we're actually trying to find here is the length between our 2 points. So once again, 2, 2 and 3, 6. So if we simply took a ruler and measured that, and if our ruler was like the same units as this coordinate grid, we could see the length of that blue line that I've just created. It's easy to find the distance if it's horizontal. That distance there in red is almost 3. This distance going down would be, whatever that is, 1, 2, 3, 4, 5, 6, 7. That length of the vertical line is 7. But once again, we're kind of at a slant here. We're trying to figure out a distance, but we don't have any way to measure it. So what we're going to do is draw in a right triangle. So using your pencil or straight edge, go ahead and draw a line going down. We're going to make a right triangle out of this, going down and over. So what we're going to do is count the distance for each of the legs here. This leg is 1, and this leg on the vertical part here is 4. And we're going to figure out what that hypotenuse is, what C is, because we've created a right triangle. So plot your points, find the length of the legs, and then use the Pythagorean theorem to find the missing side. So a squared plus b squared equals c squared. We know that a and b are our legs. So 1 squared plus 4 squared equals c squared. And we'll do all this math out here. 1 plus 16 equals c squared. And we have to figure out, to solve this here, we have to do the square root of 17 on both sides. Or the square root of 17 will give us what c is. And we'll get our calculator out to do that here. Square root of 17, we can type it into our calculator. Turn that guy on. We want to do the square root of 17. Yours is a little different than mine, but square root of 17, hit that parentheses and hit enter. Again, the square root is hitting second and then the x squared key. I'm going to round to the nearest tenth in this case. That's usually what we want to do, but take a look at the directions, make sure you're doing it correctly. This would be 4.1 when we round that, 4.1. So going back here to our notes, we got 4.1. Okay. And hopefully that makes sense. It should be, the hypotenuse, that blue length, is my longest side of my triangle. That's always the case, and 4.1 is just a little bit bigger than 4. So that works. So to go down and kind of write out the steps that we just did, first thing we're going to do is plot the points. Okay, we'll have 2 points, and those 2 points will then draw a right triangle out of that. So we'll draw a right triangle. And then after that, we'll use the Pythagorean theorem. To use the Pythagorean theorem, we're always going to be given, we're always going to use a and b values. We're always going to use the a squared plus b squared part, because every time you set up your triangle, it's going to create legs as the distances that you know. That's kind of the nice thing about it. For those of you that got that down there, we'll do the secret video code right now, and we're not going to write it in that box. All I want you to do is fill in this top left square. That way I'll know that you got this video and watched it, rather than just kind of copying from a neighbor there. So those are the steps here. Pretty straightforward. In later on in high school you'll learn the distance formula, and it's this whole big long thing. x2 minus x1 squared plus y2 minus y1 squared. Big long formula. And believe it or not, this is actually related directly to what we just did. But it can be kind of confusing with how you plug things in. So you will learn that later on in Algebra 1 or Geometry. Okay, so next question, we'll go ahead and do our steps, just kind of how this all works out here. Plot your points. We got negative 3, 3, and 2, negative 9. Remember, it's always x, then y. So we're going over to 2, down to negative 9. And here we have a pretty big triangle here. So we'll draw on that right triangle. And you might have been thinking, well, do we have to go down and over? Well, not necessarily. We can draw two right triangles, actually. We can go over first and down, kind of like we do with slope, actually. But remember, we're not trying to find the slope. And if you have a ruler, it would be best. Wow, this is really ugly. Sorry, I'm gonna back it up and use a ruler here, sorry, or a straight edge. Go over, and down, and I'll put that hypotenuse in a different color. So there is my right triangle. Let's fill in the missing parts here. We're just simply counting boxes or looking at the length here. 1, 2, 3, 4, 5 for the horizontal length. And down, if you want to look at just the values, it's for a y value of 3 down to negative 9. If you subtract those, you get 12. So here we'll do 5 squared plus 12 squared is equal to our value there, our length, our distance, c squared. And when we do that, 5 squared is 25, 12 squared is 144. I'm running out of space here, sorry about that. 25 plus 144 is 169. And when we do the square root of 169, that is actually a perfect square, it's 13. And this is actually called a Pythagorean triple. It's a common occurrence of integer whole numbers, 5, 12, 13, or a lot of you know 3, 4, 5. There's a bunch of different right triangles, or right Pythagorean triples. If you Google it, you'll find a list of a bunch of them. And those are just common ones that always give you whole numbers. Okay. What I'd like you to do is push pause and try the next one on your own, see if you got it right, and then push play to watch the solution there. Okay, so I'll go ahead and show you how this one works here. Over and down, this will be our distance here. 1, 2, 3, 4, 5 is the horizontal distance, and 3 is the vertical distance. And we are going down, actually. You would normally calculate that as negative if you're doing slope, but when we're doing distance, distance is always positive. So we don't have to worry about negatives at all. 5 squared plus 3 squared equals c squared. 25 plus 9 equals c squared. When we add 25 and 9 together, we get 34. And when we do the square root of 34, in our calculator we can round that to the nearest tenth. And when we do that, we get 5.8. And just to double check, if you put 5.8 back in here up in the grid, verify that that is actually the longest side of those three. 5.8 is bigger than 5 and 3. So that's good. And then we'll do some word problem and applications of Pythagorean Theorem. We're going to do a bunch of practice work in class on this. So I'm just going to show you two examples, and quite honestly, all the examples are going to be completely different. You know, the picture you have to kind of construct on your own and really see what's happening. Sometimes you'll be asked to find a leg. Sometimes you'll be asked to find a hypotenuse. You know, sometimes you'll be asked to find a couple different things and kind of put it all together, some multi-step questions. So this one says if a 13-foot ladder is placed away, or 5 feet away from a wall, the distance from the ground straight up to the top of the wall is 13 feet. Will the ladder reach the top of the wall? So let's build a little picture here, see what's going on. Here we got a building, and then we got a ladder. So if we put a ladder up along this building here, and you'll see, you know, these are pretty common types of problems that you'll see. So we'll kind of build this as our ladder here. We know that the distance from the wall to the base of the ladder is 5 feet. And let's see here. The ladder is 13 feet. And it says the distance from the ground straight up to the top of the wall. So that would be from here to here is actually 13 feet. So for putting the ladder up against the wall, basically we want to see where on this wall it's going to end. So this ladder is going to kind of swing out. So the ones that we know right now are this distance here and the ladder height. We just don't know for sure that this is really 13. We don't know where that's going to actually reach. So we'll kind of ignore that for now. And we'll set up the Pythagorean Theorem. And we know that we don't know the height, or one of the legs. And we know that one of the bases, or the other leg, is 5. And the hypotenuse is 13. So when we do the math here, we get a squared plus 25 equals 169. And then we'll solve for that a squared, so subtract 25 out. I'll go over here. We get a squared is equal to 144. And that should pop out into your head as a perfect square there. We know that that is 12. So we get, a is 12. So we know now that that actually is the height of the building. The height of the building is actually 12. So let's go back and see if we can answer this question. It says, will the ladder reach the top of the wall? So the top of the wall, I should have actually drawn this picture a little differently, sorry. So let's say the building ends there. The top of the wall is 13 feet. But we're saying that this distance here, if I clean this up a little bit, in here, this distance we've just figured out is 12. So the ladder is only going to go up 12 feet high, but the wall is 13 feet. So no, the ladder will not reach. Okay. Next one, number 2. Janet and her friends go on a hike. They hike 7 miles east and 3 miles south. So they'll start here. We'll just draw a little diagram. Remember the compass directions. They're going 7 miles east. And then from there they're taking a turn and going south for 3 miles. And how far away are they from this starting point? Well, you'd probably say, well, they were 10 miles away. Well, that's how far they've walked. But if you just look kind of as the crow flies, the straight distance from the point to where they are, that's what we want to know. So, set the Pythagorean Theorem up. 7 squared plus 3 squared equals c squared. And I'll just quickly go through this one here. 49 plus 9 equals c squared. 49 and 9, add that together, that gives me 58. And if we do the square root of 58 there, oh, I didn't do that one yet, somewhere less than 8, 7 point something I would imagine. Square root of 58 is 7.6. So that would be how far they are in miles from their starting point. Okay. When you come in tomorrow, we'll do quite a bit of these practice problems with drawing pictures and using the Pythagorean Theorem in reasoning problems. Thanks for listening, guys. We'll see you tomorrow.